Are we going to have a challenge with desktop sharing versus application sharing?
Let's find out. How does that look?
So that I see your slides.
That's a good start. That's a good start. I will switch to share my desktop in a bit when I get to the live demo, but we'll see how all that goes.
No worries. Cool. So I think we're pretty much at time. So if you want to kick off when you're ready, Robbie.
Absolutely. Thanks, Simon. Okay, so good afternoon, everyone. I'm Robbie Jerram. I'm a Principal and Solution Engineer at VMware, and I like to talk about things that are coming from VMware soon, on the horizon, or interesting things that might break. So today I'm going to talk a little bit about the Tanzu build service and the Tanzu Cloud Native runtimes, how they fit into the kind of bigger picture of apps, and how it's just going to make life easier for everybody. As I go through, please ask questions. I'm pretty certain I don't have a full 45 minutes worth of slides, and I've already broken my demo. So ask questions and we'll have a bit of a longer discussion. So to start with, a bit of a history lesson. Way back when the world was new, building software was difficult and slow. And then came this amazing solution, this PaaS solution in 2007-ish, called Heroku. And it was incredible. It was built on the premise of taking my source code. It would work out what the code was. It would then build the code and deploy it into its PaaS platform. And way back in 2007, that was unheard of. And Heroku spawned a whole bunch of interesting pieces of technology, including Cloud Foundry and Docker and stuff like that. 2009, we had version 2 of Heroku and Cloud Foundry emerged, both with the same premise: here's my source code, run it. I really don't care how. That was magic. It was kind of visionary, but it was very opinionated. So it was difficult to do everything that enterprises needed to do for those solutions. But the fact that you could understand the source code and then just build it was very clever, and that persisted through to 2018, 2020, where the folks at Pivotal and VMware came together with the folks at Heroku to create the Cloud Native Foundation build packs. So build packs have been a concept for over a decade now. Just understanding what your code is and how it's built. But in reality, software, I say, used to be built like this, but most enterprise software is still built this way. We have virtual machines or physical servers. We have Java virtual machines, and then those build pipelines are typically Jenkins. And Jenkins has a number of VMs that are effectively build servers that sit underneath them, that take your software, take your code, and follow a very prescribed set of instructions as to how to build that code. Back when I was doing this stuff for a living, building WebSphere, we had build scripts that created make files, that created Jenkins configs that would eventually then start building your code. And the Jenkins build farms that we had were huge. You would have master node, you would have 20, 30 agents on other virtual machines just building Java code for my application. And it was incredibly complex. And the architecture on the right-hand side of this slide is an actual architecture around a build environment for a data platform that I was reading about on the web, and I just love the graphic that it highlights how complex building software can be. Installing plugins, configuring build spaces, making sure you don't run out of storage, auditing all of those changes. So when you build a new version, making sure you've got the exact right pieces in the right places so you can reproduce that build if it goes wrong. It's incredibly complicated. And that's why you have build teams. Most organizations today still have a build team, or at least one individual that understands how their software product is built. And that's all they do. They don't do any code, they don't do any feature work. They just understand how to build the thing, package it, and push it out. And that's time consuming, it's complicated, it's risky, it always has been. But it's started to become easier. And the concept of what we did with Heroku and Cloud Foundry, moving that forward to enable you to build software the way you want to build it, which is slightly less opinionated than the likes of Cloud Foundry and Heroku, is at the heart of build packs. Build packs keep the intelligence but give you that flexibility, predominantly because we now have Docker and we have Kubernetes, and the world of software engineering and infrastructure teams all rejoiced because it's all very easy to understand and manage and all of that stuff, which may or may not be true depending on where you sit in the world. It's possibly not simple for everybody, but it certainly made the process of repeatability much easier when you're building software and then deployment inside Kubernetes. So as I said, Heroku wasn't just magic. Developers still had challenges, and that was around all they really needed to do was write code. They're writing business code, they're writing applications to solve business challenges, but there are a number of steps to packaging something into Kubernetes and building it in a Docker container. So to start with, we have Docker files. So we take the application component, we describe in the Docker file how to build that particular piece of software and how it's labeled and how it interacts with other pieces. So now I've got another artifact that I need to care about, I need to look after. I need to version control and make sure it's up to date and check. And that gives me my container image, which I need to label and tag and push to a repository and look after and check. And then I have the actual how to deploy the application itself. So this is Kubernetes resources. This is how it actually deploys into Kubernetes, what persistent volumes it might need, what other pieces it might need to be successful. And then the services themselves. What am I going to call them in Kubernetes in production? And I need to synchronize those and make sure they're consistent and version control all of those config files as well. And then finally, I get to run it on Kubernetes. So as a developer, I have to do all of these steps. The writing code is the valuable piece. That's where I'm using my brain to create the next Netflix or something like that. And then everything else there is quite a distraction. It's important. I need to do all of these things to get my software into production and to enable it to scale and use the features of Kubernetes. But it distracts away from building my application. So that's not really where I should be spending all my time. And there are other concerns as well. So this is actually quite a long process to getting my code into a deployed environment. I mean, it's certainly not as long as it used to be with Jenkins build farms. And, you know, in that world, if I needed to build something new, I'd spend weeks creating a new build environment for it and deploy that somewhere in a bunch of VMs in a Jenkins farm or have to stand up my own. So it didn't take me weeks to write this stuff, but it would still be long enough to let me lose focus maybe on the code that I'm writing, and it's distracting me away from the actual business logic that I'm trying to solve, the feature work, the actual value to the organization in building all these different pieces. And then there's a big part around security and consistency. If I'm one of 10, then maybe I can synchronize with everyone else in my team around Docker files and labels and configurations for my Kubernetes deployments. But if I'm a large organization with lots of different teams doing all kinds of different things, keeping these pieces in synchronization is a challenge, and making sure they're secure is also a challenge. When I'm building an application and I'm using a base image, say Ubuntu as my base file system for that container image, making sure that that container image is secure, is up to date, is the latest version, is time consuming. And if there's a CVE in a tool inside that container image, I need to be able to catch it. It's my responsibility as a developer to make sure I'm writing secure code. And that includes all of the layers of that Docker file that deliver the application end to end. Now, I may have a DevOps team that help me with that and look after it. But fundamentally, how I package up the specification in the Docker file, how I build my app, the security of that is my responsibility. And if there is a vulnerability, I need to go back and I need to edit those Docker files. I need to change them. I need to fix the problem. So if it's something like a heartbleed or something like that we like to refer to because it's an easy one, but we need to go back and fix it. So I need to edit all of those Docker files. I need to version them. I need to redeploy the images. And it takes time, and it distracts away from me writing my code. So if I'm spending too much time distracted, what can I do about it? What should I be doing about it? Well, really, I need to automate that. And it's the same as what we did with VMs. Automate as much as possible to get the pipeline through to production as seamless as possible, as smooth as possible, as consistent as possible. So taking away the responsibility of creating those Docker files, building the images, defining the Kubernetes resources, accelerates my path to production. We still want control, we still want audit, we still want security, but we don't really want to do that ourselves. It'd be much better if the machine took over that responsibility, and that's what we're doing with Tanzu Build and with cloud native runtimes. Tanzu Build is responsible for understanding the application and writing, the Java code, the Go code, the COBOL code, if it's even COBOL, and creating the container image. And then cloud native runtimes, effectively serverless component from Knative, gives you the ability to deploy it into that Kubernetes cluster and configure up all the things you need, all the services, all the things like SSL certificates and stuff like that, handle scaling for you. So you're reducing the complexity of that production side as well, just to get the application out to be able to test it and run it. So that's awesome. So taking source code and saying, just take the code, work out whether it's Java, work out if it's Java 11, Java 13. If someone's created some Go code in there, just work that out for me as well, and create the containers required. So now if I'm writing some Java code and I'm using a feature in Java 13, the build service is going to work it out. It's going to package the right Java runtimes for me to deploy into production. I don't have to go into a Docker file and say, actually, now I'm using Java 13 for this, increment this version. It's going to work it out for me. So it takes care of all the updates. It takes care of all the dependencies. And if I'm building an application that has a whole bunch of things like a Spring Boot application, it's going to pull all of those pieces for me as well. So I don't have to care about it. It's just going to look after them. But what's really nice about this is in enterprises, we don't necessarily want everyone just pulling stuff from the internet. That's possibly a bad idea. If I've written some code and I'm using a repo from bobsrepos.com, and it's an encryption algorithm that I really like because my mate wrote it, I don't necessarily want that to be part of my build. Enterprises don't want that to be part of their software stack. The same with licenses. Lots of open source software has different licenses. So we need to make sure we're compliant with licenses. So what we can do with build service is we can either leave it fully open and you can download whatever you want from the internet and build the application however you need, or you can create a subset and we can say, this is our marketplace of known base builds. So this build environment knows how to build Java 13. It knows how to deploy Spring. It knows COBOL. It knows all of these pieces that as an enterprise are acceptable for us to be able to deploy and build applications against. So it's giving us control. And I can do that in an offline mode. So I can download all of these build packs and tie it down. So the safest way of building software, if you're not sure what's being downloaded and packaged up, is to build in an isolated environment. Press some magic, apply some NSX magic, deny the build environment access to the internet. That way, the software that you're building is from known repositories, safe locations, and you can't have a developer accidentally introducing an artifact that just shouldn't be pulled down, shouldn't be built. A big concern with security today is open source projects that are being contaminated over a number of months or even years to introduce exploits. So organizations are very, very concerned with this is an open source component. That's fine. We understand it. We know this piece. We've audited this particular piece. We don't need any more functionality on this at this time. This is the version we're going to build against. So applying that as the base image, the build packs you can work against, helps you guarantee the quality of the software that you're building. You're not accidentally going to be picking the latest version that may have something in it that you're not aware of. So reducing risk by controlling the build. And then on the other side here, we have cloud native runtimes, and that builds the Kubernetes resources. So that looks at the container images, that looks at what's being deployed, and takes care of revisioning, URL generation, lets you scale down to 0. So it's being able to make more effective use of your Kubernetes cluster and not having to hand crank any of these pieces. So when a new piece of code is deployed into the cluster from a build, a new container image, a new application, I can create a revision. Say this is revision 2.0 of my application. The Cloud Native Runtime is going to come back with the URL. It can create the HTTPS certificates and all of that stuff for you. And you can handle traffic as well. So we can say, based on demand, start at five instances of this, automatically scale up based on demand to a maximum of say 20. Or if there's no traffic coming into the application, scale down to 0, save my resources for something else. So we can start to be very efficient with it, all without having to manually configure these things. I don't have to go in and scale, say, deployments down to 0 to scale the application down. I can scale back up based on requests that come in. So we're making the runtime as flexible as possible as well. I can balance traffic between them. So if I've got version 1 and version 2, I can split 50% of the traffic between the first version, 50% between the new version. Observe the results. If it's going very badly wrong, the application isn't responding how I want, I can redirect all that traffic to the old version that's already running. That old version will automatically scale up to handle that demand. And I can go back and fix whatever the new changes in my code were, push them through build service, get a new container image, and try that loop again. So it's a nice fast iteration to fix problems without me having to go in and manually reconfigure all these different components inside Kubernetes. So that makes sense, folks? Silence. No sense at all to anybody.
Great, Robbie.
Cool. I mean, it's as I said, there's a big beta logo over the Tanzu runtime for a very good reason. It is definitely beta at the moment, but build service is GA, and that's part of Tanzu Advanced, and that's out there today, building and doing magic stuff.
Can I just ask a quick question on that, Robbie? So where the build service is looking at those container images, etc. I mean, does it do scanning of that natively, or does it have a hook out to some other kind of scanning tool set?
It's not doing vulnerability scanning. So your repo will be doing that for base container images. But what it will let you do is lock it down and say, actually, you're only allowed to use this version of Ubuntu as part of build, or this version of Java from Oracle's certified containers part of your build.
Yeah.
So you can restrict access. It's not going to do vulnerability scanning. But what it will let you do is, if there is a vulnerability, you can explicitly say, replace this layer of my build with this layer that I know is good. Without having to rebuild the whole application.
Sure. I mean, can it do some kind of chain of custody, or look at hashes of known images in your repository, for example, so that they haven't been sort of tampered with on the way?
Absolutely. You can refer to the images that you're building through the hash directly, so you can make sure you're building against exactly the image is approved, is tested, and is consistent with your prod environment. So you aren't limited to just version 1 or whatever it's been tagged by. You can use the SHA on layers.
Cool. Thanks.
Cool. Okay. So quick word of warning. The combination of Tanzu build service and Tanzu runtimes is not a full CI/CD pipeline, which I think touches on your point, Simon. There's lots of other pieces you need to put into your pipeline to deliver that end-to-end automation for path to production. Okay, this is a build component that does a great job at understanding the code that is being presented to it and packaging up and building that into the OCI compliant images. And then the run side is great at taking that image and saying, this is what I need to run it. And based on the config you've given me, I'm going to scale starting at 0 instances. And when I get an HTTP request come in for this application, I'm going to quickly cache that request, spin up an instance of the application, deal with the request. And as more traffic comes in, I'm going to grow the number of instances of this application to scale appropriately automatically. Or it's going to handle traffic balancing and stuff like that. But the combination of those two things does not give you a full CI/CD pipeline. You still need to do your testing. You still need to do decent load testing. You still need to do lots of other automation around this. Plug that into maybe a security scanner or an audit tool. So that this isn't replacing tools like Argo or Tecton in the Kubernetes world. It's just making individual parts of that pipeline easier to configure, easier to manage, and therefore easier to understand when you start delivering this as a service. And I often get asked, well, that build thing isn't responsibility of an infrastructure team, but that run thing is. But in reality, as software, and we all hear this all the time, but as ops and developers start to become closer together, they're both working with Kubernetes platforms in slightly different ways. Sometimes they don't have any idea how either side of these things work. So bringing dev and ops closer together and giving developers the ability to use cloud native runtimes to provision a test environment that auto scales means they can test their software more effectively. Using the same CNR cloud native runtime inside an operations environment where you're running thousands of instances means that you speak the same language as the developer that tests it on 5 instances. So when it does go wrong, you can go back and you can say, look, this is what we've built. This is how we deployed it. We're deploying it in the same way as you're building and testing. And that configuration is the same as in your pipeline. So you're bringing the languages closer together. And that generates interest from dev and understanding from ops as to both worlds. And it works quite well. And generally, I see dev and ops teams now working together on those pipelines, either delivering them as a pipeline service or just sitting with the developer saying, look, what are you building? How are you building it? And what other parts of that CI/CD pipeline are you putting in? If they're using linters to optimize the code, understanding what that is doing, what that's ripping out, what that's changing can be interesting to an ops person. So those are all sort of parts of these pipelines. And then on the tail end, depending on what you're doing sort of in the whole GitOps arena, having that pipeline actually provision up the Kubernetes clusters, deploy cloud native runtime into it, then deploy the application into it completely from clean is very attractive to some organizations that want to make sure their environments are as clean or secure or running as cost efficiently as possible, depending on where those workloads are landing. So I'm sure there'll be future VMworld sessions and VMUG sessions on Argo and Tecton and the whole CI/CD pipeline running in Kubernetes coming soon, hopefully. But these are 2 pieces of that puzzle. They're not an end-to-end solution. Okay, so how does it work? I've talked a little bit at a high level. I'm going to go into a little bit more detail now. So with your Kubernetes cluster sitting at the bottom, we deploy Tanzu Build Service. Build Service effectively has a service called Custom Builder. And the Custom Builder is responsible for understanding the source code and consuming creating stacks from what we call the store. The store effectively is a marketplace of known components that you're allowed to build from. So the store is where you would put Java 13 images, the Go builder. If you had some COBOL code, you put the builder in there for that. And then when you create a stack to build your application against, that stack consumes from that store. So when we look at the code, the source code is going to be the stack, the custom builder builds it. it consumes from the store of what available images are available to you as part of that build stack. That's going to build the image, push that out to a container registry, and be your application. Knative serving, which is the cloud native runtimes, is going to consume that container image from that registry when it's ready to go. So as I say, demo time. I always like to build a live demo and show something. We'll see how well that goes today. But what I've got to talk around is a Spring Pet Clinic application. So Spring Pet Clinic is a Java microservices application that we use for all kinds of sort of education, training. It's been around in the world of Spring and Java for a very long time. So it's a great demonstration of various parts of software architecture and deployment. I'm going to use that in my Tanzu build environment to build a version of Spring Clinic. That's going to push out to Docker Hub, and that's going to give me my container registry. And I'm purposely making this both internal and external to show the variance here. And then Cloud Native Serving is going to pull those container images, deploy those into the Kubernetes platform, the Tanzu platform, and it's going to secure those with Let's Encrypt certificates that it's going to automatically pull down when that deployment happens. And then the logs of those builds and that activity, because everything is in Kubernetes, is treated the same as everything else. So if a build is failing, the code isn't compiling, or it's not assembling correctly, all of those errors are just events or logs inside Kubernetes. So you can consume them however you want to consume any other Kubernetes log, or you can just forward them off to a development team to look at later. So there's consistency in how you understand the platform. Now the logs for the build environment are in the same place as the logs for the production environment, or the events for pulling images from Docker Hub, for example. So everyone is using the same tool sets and the same terminology to understand what's going on, whether it's broken the Java code, broken an SSL certificate, or there's a permissions problem. It all happens in the same place. The logs are all in the same place, and you can see what's going on. So that's what we're gonna do today. We're gonna deploy some code, build some code, and then hopefully push it out into production. So I'm going to switch. Oh yes, and none of this is also on vSphere. I thought it'd be an interesting experiment. I normally build everything on vSphere and run everything on vSphere. Today I'm not doing anything on vSphere. This is Tanzu deployed onto AWS. This is certificates from Let's Encrypt. I'm not even using Harbor as my repo. I'm using Docker Hub as my repo. And GitHub as my source repository. So lots of different pieces. And as I said in the chat earlier, not all of those pieces are actually working the way I want. But yeah, this worked nicely on vSphere, then I moved it to AWS and it's become complicated. But I'll get into that in the live environment. So let me just switch to my screen. All right. Oh, why can't I share just my desktop? What's going on?
Yeah, I think this might be a policy. I think this is a Zoom policy challenge with UBS. I think when you're sharing externally, it doesn't allow you to share your desktop. It allows you to share windows.
Okay, I can get around that. 1 second. No, I can't. That's not going to work. Okay, we might get a very boring console window for a while then. No, I'm going to be switching. That's not going to work. I'm going to be switching backwards and forwards. Any suggestions, Simon?
Depends where you want to run your bits from. We've cheated it in the past with RDPing to something and sharing the RDP window, but I don't know whether that's an option for what you're doing.
That might. Well, let's try that.
Yeah, it seems to be a policy that's set on the VMware side. I think it's okay if you're sharing internally with other VMware people, but where you're going externally federated, it doesn't let you.
Right. Okay. Let's see if this will let me do it. No. Okay. I'll switch between windows and see how we do. Okay, so what are you guys seeing right now? Is that just
build logs consoles?
window? Okay. Not sure how well this is going to show, but we'll see how we go. Actually, if I take that, I can share a single terminal window, then I can split that out. Let's do that. All right, is that, are you seeing a multi-tab tab console now?
Yeah.
Okay, so I've got my Kubernetes platform. I've got my Tanzu build service deployed into that platform. I'm just having a quick look at my cluster store. So if I clear this, I'm asking the cluster what it knows how to build. So these are particular build packs from VMware for building Java, Nginx, Node.js, Go applications. And I can add to that store, whatever I want. So I've got the predefined packs available from VMware that we look after, we certify and we check for security, etc., etc. I can also add my own. So there's a Payco build pack up there. There's build packs available for pretty much every language, I think. I mean, I was looking at a COBOL one the other day just for pure interest. So I can load those into the store and make them available for anyone who wants to build their application. So that's what's available for me to build. Now, if I want to build something, let me just stick the build logs in a different window. Okay. So if I want to build something, I can just submit that build environment to the build service and say, this is my GitHub repo. This is where I would like you to build from. So for my application here, if I want to deploy, I want to add that, I can create what's called an image that will let me build into or take advantage of build service. So if I go from my console here, I can do I'll just paste this in. So I can do a KP, I can do KP image create. So create me a new image. It's called Spring Pet Clinic. This is the Docker repo I would like to push it to. And this is the source code of the Git repo where the code is. I want to build against the main branch of that code, and I want to push it to this namespace, so the TBS demo. And that's going to, so it already exists, that's going to connect the build service with the source code repo on GitHub and the Docker repository where I want that image to be pushed to start the build and kick everything off. The build takes about 15 minutes, so I've already pre-built that, pre-cached all the images. What I'm going to do is I'm going to make a change so we can see the build kick in. So any time a new commit is made to the Git repo in the main branch, Tanzu build service is going to pick that up. It's going to rebuild the images for me and make them available on Docker Hub. So if I go to my watch, it's a shame you can't see me change the code, but I'm just going to make a quick change to the code, push that up to GitHub, and it will detect that and start building. Let's keep this watch off. Oh, there we go. So it's detected that there's a new code build. It started the build process. Spring Pet Clinic. Then why my logs aren't coming up. Hold on a second. Oh, it's still building. So if you head over to Docker Hub, that's the repo that is currently being built. So you'll see that populating and building. It's a shame I can't share that on the screen. Oh, it's finished. Okay. So now it's made. Now it's finished the build. I can just push that down to my environment and say deploy that image. So I can now switch to Knative serving, and I can say to Knative, deploy my application for me, and make it available. So I can say Knative service. I don't want to update. I want to build. I want to create Pet Clinic. create my pet clinic, which is a revision, which is the name of my deployment. This is my image from Docker Hub that I want to deploy, and I want a minimum scale of 3 of these at any given time. If I were to set this to 0, the deployment would sit and wait until someone hit the endpoint URL, and then it would spin up an instance of that application. What's great about this is, though, that even though there's no instance available, no pod running when that request comes in initially, that initial ping is held and replayed effectively when the container becomes available. So we can scale right down to 0, and we're not going to miss any requests coming into this service. So now Knative is pulling down the image, it's configuring up the pet clinic, it's setting up the network. It may or may not be going off to Let's Encrypt to get me a certificate endpoint, because that was the problem I had with the lab environment. So there we go. We've got my application deployed. If I do my Knative service list, this is my pet clinic here. This is the URL it's deployed to. This is the latest revision that it's got, and it's running 3 instances and it's ready for traffic. If you go to this endpoint with your browser, you'll probably get an error message. If someone could do that and tell me, that would be great. Yep, I'm getting an error message. So the reason that that's throwing an error out is because I'm deploying this platform in AWS. It's automatically trying to switch to use HTTPS to stop cross-domain certificate cross-domain issues. So the load balancer is an AWS name. My application is deployed on tanzu.app, and the backend services have got different names themselves. So by default, the browser request will switch straight to use HTTPS. I did configure up the Let's Encrypt issuer inside Kubernetes to automatically pull that piece, which is once again something you can set up in Tanzu runtime. But I think I've hit an API limit where it's not issuing certificates anymore. So I need to create a new identity or wait for that to come back. When I'm allowed to issue new certificates, that will switch to HTTPS, and you'll be able to hit that and see the application. But I don't think that's going to be today. So the next thing I want to do is just deploy another instance of the application. So if I push down another instance of it, I don't need to create another build. I can just deploy another and give it a different name to give it another revision. I need to give it the right repo though. So now it's creating another revision of the application. So if I had a build service update the application, push that to GitHub, push that up to GitHub, push that up to Docker Hub, I can say to Cloud Native Runtimes, deploy a new version of my application, and then I can choose to balance the traffic between those two and evaluate what's going on. So it's once wait for that to come back up, and then I'll just set a policy around balancing that traffic. Oh, there we go. Okay. So now if I look at what I have in terms of services, I've got version 3. And here's my revisions. So because I provided the wrong repo here, I've got an image, an error saying that this is not a valid revision. And so I can delete that. This is a bad deployment. I don't want it I don't want it messing things up. I've got version 1 and version 3, or generation 1 and generation 3 of my application. Now, if I wanted to balance the traffic between them, I could say update pet clinic, and I want to change the traffic for this version here. Version 3, which is my new version, can have 20% of the traffic. Version 1, I want 80% of the traffic. So now the traffic is automatically routing between two different versions of my application, so that I can make sure that everything's good before routing 100% of the traffic to version 3. So once I'm sure everything is happy, I can say, right, route everything to version 3, and I'm good to go. But if something does go wrong, I can go back to previous revisions of those deployments, and I can have as many of these as I want. I can clean them out, but effectively, because they're not using much resources, they're sitting at 0 pods running unless something hits them. I can easily roll back to previous versions, as many as I want. And I can, because this is Kubernetes, I can put name tags on these, selectors on these. So I can put detail behind each one around what a particular change was, for example. So if I do kn service describe, so I can see specifics about that particular image. So what image it was pulled from, what version, what it was pinned to, how long it's been running, all those kind of details. If I describe the particular revision, it's going to give me specifics about exactly what I'm running, what policies around it, what labels, what namespaces. So it gives me details about those deployments, even if they're not doing anything. So I've got a nice way of building an application in an automated fashion. I can choose what particular layers of an application are there based on the shards, or I can pull that config from the net or consume it from a marketplace using the stores that I've predefined. And when I come to deploy that out using container cloud native runtimes, I can scale from 0. I can set policies on how to scale up and scale back, and I can automatically create the HTTPS certificates and then deployments around them. So I've got a very easy way of taking code from lines of code in a Git repo, building it and pushing it down into production very easily. And that is unfortunately just a console demo, but hopefully that was useful. Any questions on any of that, folks?
It's really good.
Yeah, really good. Thanks, Robbie.
I mean, just I mean, obviously we're only able to do the console demo, but does that then imply there's a kind of, I don't know, is there a web-based UI to navigate that in a slightly less command line fashion?
No, it's very developer-y, so it's very command line, but the goal of it is it just gets built into a pipeline. So you really want it command line.
Yeah.
It's more useful to have, so I have Octant running, so you can see the pods scaling up and scaling back. And if you're watching the build logs and the application run logs, you can see the app starting and responding to requests. So the desktop was just to make the demo more interesting for you folks. Most of the stuff that's coming out of Tanzu build, cloud native runtimes, it's all command line by intent. Now with Octant, there's already a cloud native runtimes plugin. So it understands that you're running using cloud native runtimes, and the GUI changes to show you more of a real-time view of what's being deployed and what's being configured. So it's those third party, it's those open source plugins that give you that kind of GUI experience when you're trying to understand what's going on.
Cool. I mean, just in terms of telemetry, I mean, I mean, obviously you can have conditional branches and things like that in your build scripts based on output, but is there somewhere central that you can send telemetry data? Because if I think about the way potentially do some of that stuff in some of the other sort of large cloud providers. You can pump all that kind of log data at a logging solution. Do you have a similar sort of capability so you can see where you're starting to have failures?
Yeah, absolutely. Because it's all using Kubernetes primitives. They just go to Kubernetes logs, so you can pipe them wherever you want. So if you've got if you've got build tools that analyze that already for you, you can just consume those logs. You can push it to a log insight or or whatever you want, or a Splunk, and just interrogate it from those places. It's the same as if you've got build failures and you want to be able to trigger events based on those failures, you can watch those logs and just pick up on those events and send out push notifications to developers if you want. You can use the the cloud the AWS messaging services to send text messages to dev teams if things are failing, builds are failing. But because it's all effectively using the same fabric, you've got a lot of flexibility as to how you choose to interact with those teams. So when I'm playing around with this internally, whenever there is a code commit going up to something I'm working on, you get a notification in a specific Slack channel. And if the build breaks, you get a chunk of you effectively get 10 lines of the previous log showing you where the break happens. Because ideally, no one should be pushing code into a repo that's going to break it. But if it does, you can quickly see what the error was, what the break was, and who made the last commit into that branch. So you've got that flexibility, and it's very easy to configure and very easy to set up. And that's the goal with a lot of this stuff. Is it's easy to integrate it into the systems and services that you're familiar with. The batteries are included but changeable, as they say.
Yeah, I'm envisioning an API to send the lads around when things break. Rather than
exactly. But if you start to automate this stuff, which is what you want that path to production. But equally, you absolutely need to be able to roll that out or to fire up the fireworks if something has got to production that is causing a problem. And one of the nicest features of Tanzu Build is that the Spring app, for example, that takes about 15 minutes to build. But if you are building a big enterprise thing, that can take a lot longer. If there's a vulnerability in one of those layers, or you need to change one of those layers from Ubuntu 16 to Ubuntu 18, you can change it in the build in Tanzu Build, and it's going to rebuild all of those pieces that are dependent upon it. But it's not going to. It's going to do incremental building. It's not going to respin everything. So it gives you that control on the build side, where you're not going to impact things you don't need to, and you're not going to have to rebuild everything just because you need to move to a new supported file system that you've built your applications on. So it gives enterprises more control and more visibility, and you won't find that your Spring application or your Java application is using a Java library that was built a decade ago and no one realized, because you've got that visibility into what's being built and how it's being built. I think I'm out of time, but
yeah, so we're in a break technically. So I think we start at the top of the hour for Gary's session. But have we got any more questions for Robbie? Just not to let him escape early.
Well, thanks for staring at my console for the best part of 20 minutes. Sorry it wasn't more graphically exciting. Next time I'll make it better. No questions. All right. Thanks very much, folks.
Thanks.
Cool.
Thanks, Robbie.
Cheers, Robbie. Thanks, Matt. Good stuff. So, Gary, I can see you joined. So we've got about 5 minutes or so before we get in. So we just got a bit of a break, and then we'll kick into yours. Do you want to just check that if you've got material, do you want to just check you can share it? Because we had a couple of challenges earlier.
Yeah, no worries. Let me give that a go.
Yeah, I've been having a bit of a discussion in the background with someone at VMware. I think it's more of a policy restriction from the VMware side than anything else. Cool.
I've never seen it before, Simon, so it must be a new thing.
Yeah, we had that on a previous meeting as well. I think we had the same challenge with Vern earlier. I think it's when it's an externally hosted, because it's coming from a vmug.com user account that owns the account. That owns the meeting. Bit weird. Need to debug it in a bit more with IT.
Yeah.
That one's working?
Yeah, I can see the slides, Gary.
Excellent.
Cool.
No one's resorted to pointing their camera at their computer yet, though. So
Yeah, we've cheated it in the past by RDPing to a machine and then and then sharing the RDP window.
technology, isn't it wonderful?
Indeed, yeah. Right, I'm just going to grab a quick drink before we kick off. So we'll kick off at the top of the hour, Gary, if that's okay.
Perfect. Thank you.
Right.
Yeah, we've got co-host. She'll be ready to go.
Okay, so I think we're pretty much at the top of the hour. So Gary, if you want to take it away. I'd just say as well, when I mentioned earlier about our call for papers, right? So, I think both Gary and Gareth actually today were people who submitted via the call for papers. So, spend 2 minutes filling in a Google form. Look at all the glory that you get. But take it away, Gary.
Excellent. Thanks, Simon. Let me share my screen. Let me know if that comes through.
Yeah, looks good to me.
Excellent. So yeah, as I mentioned, my name's Gary. I'm here today to basically talk about all things VRA and Terraform. So VRA, or vRealize Automation, cloud version, basically allows you to provide multi-cloud infrastructure and application delivery to your end users. So it means you can deploy machines across all your different public, private cloud providers, ensure that teams can collaborate together, continuous delivery and release automation as well. So VRA is available. VRA consists of sort of 3 main services these days. First being Cloud Assembly, second being Service Broker, and the third being CodeStream. VRA is available both on-prem, called VRA 8, or the SaaS version called VRA Cloud. And the best part is it's super easy to get started. All you need is your credit card. It's really cheap to learn. The list price is something like 3 cents, US cents per hour. It's available globally. And if you're already familiar with VRA 8, if your organization already runs it, the cloud version is the exact same code base, and it's actually updated more frequently as well. So nice and easy to get started. So what is infrastructure as code? Something that I think a lot of people are talking about in the last year or two, especially. So it basically allows us to manage and provision our infrastructure through machine readable config files. And of course, we can store those config files in a version control system, which allows us to sort of speed up deployment times, reduce the risks with consistent builds. And of course, it's repeatable, so we can reuse the same code across all of our different environments. So there's 2 approaches, I guess, to automation in general. The first being imperative, the second being declarative language. So imperative language is where you define the steps to achieve something. So this could be PowerCLI, JavaScript or VRO, Python, all those sort of languages. The other side of things is declarative language, which is where you specify what you want your end result to be, not the steps on how to get there. So examples of this are, of course, Terraform, Ansible, Puppet, Chef, and PowerShell desired state configuration. So what is Terraform? It's basically an open source, free, simple executable file. You write your infrastructure as code in the HCL language, and there's over 200 providers to date, including all of the VMware products. So vSphere, NSX, vRealize Automation. I think there's a vCloud Director. There's lots of different providers out there. So VMware's really been good in jumping on board. I guess the next part is how do you get started? So with Terraform, we create Terraform configuration files, which is basically just a text file with a .tf file extension. We specify the provider we want to use. So this could be vSphere, could be NSX, it could be VRA. And we retrieve data sources from the provider. So this is where we want to retrieve some information out of vSphere or VRA or NSX, which is a data source. And then we create resources. So if we want to create a virtual machine in vSphere, that would be a resource. And then, of course, we can run any post-provisioning tasks using local exec or remote exec provisioners. So once we create our configuration file, we then initialize our folder and run the plan. And what the plan does is it checks that all of your local configuration files look correct. There's no syntax errors, and it will check what you're planning to do against your current state file to see what it knows about your current environment. So Terraform takes your configuration file, your state file, calculates the plan. You can then review the plan. The plan will tell you it will add one resource if you're creating a virtual machine, for example, and you can check that that's correct. And then you can run the apply command, which is where it will create, update, or delete the resource as required. So what does this look like? Let's jump into VS Code here. So we'll start off here. We've got our vsphere.tf file. And the first thing we do is reference our provider. So we're going to be using the vSphere provider. And we're going to
see your screen, Gary. We can still see the slides.
Oh, sorry. Let me switch that over. Thank you for noticing. Give me a second. Just reshare. Excellent. How's that?
Yep, see that now.
Perfect. Okay, so we can. Sorry, I'm just getting slightly distracted. I'm sure you used to be able to screen share your whole screen, not a specific application.
Oh, that's interesting. So, so maybe it's not just VMware people, but that means it's our end. Yes, normally you can share your entire screen with Zoom.
Cool. I thought I was going crazy. You'll have to bear with me while I switch as we go through. That's a bit of a pain.
Gary, can you zoom in a little bit?
Yeah, of course.
Thank you. I think you can do Command plus on a Mac.
So with the multi-monitors, it might be a bit. Does anyone know a way to do it in code? There we go. Is that a bit better?
Command and plus, but I could be wrong.
Is that a bit better?
Yeah, that's perfect. Thank you.
Excellent. So yeah, we basically connect to our vCenter server here with our username and password. That sets up our provider. And then we've got our data resources. So this is where we're retrieving information from vCenter. So here we're going to define a data resource called vSphere Data Center, and we're going to give it a name of DC. And we're going to find that object by searching the name vSend Data Center. We do the same thing for finding our resource pool. We're going to call that pool, and it's going to look up the name vSAN cluster / resources. So that will specify the cluster that we're going to deploy to. And the data center ID will be the data source of our data center that we defined here, .dc, and it will use the ID that it's collected from that data source. Same thing for the data store that we want to provision to. We give it the name, and it will use the data center ID to find the actual object. Again, the same thing for the network. We give it the name of the port group that we're going to deploy the machine to. It uses the data center ID and finds the correct network. And of course, the same thing for the template that we're deploying from. So we're deploying from our CentOS 8 template. So once we've got all of our data sources, we then want to create our machine. So we create a resource of type vSphere virtual machine, and it's going to be called demo. And we're going to give it a name of VMUG1, 2 CPUs, 4 gig memory, and we're going to specify the data store resource pool based on the information that it's retrieved from the data sources earlier. So we'll put it on our data store with the ID field, the cluster with the ID field, and it will get the guest ID and the SCSI type from the template that we provided. So it will make sure it's the same. We then specify the network interfaces on the VM. And again, it uses that data type to grab our port group and the ID. And we predefine what the disk layout is going to be. So here we're going to specify a single VMDK with 30 gig. And we're going to clone from that template. And we're going to customize the machine and specify the host name, the domain, the IP address, subnet mask, DNS servers, and the default gateway. So that will deploy our machine for us, run a custom spec and specify and set all of that information for us. And then at the end, we're going to run a remote provisioner, and this will SSH into the machine, and it will run a script, which we've got here called scripts example script. And it's just going to echo a few some text for us. But as you can see, that will actually SSH into the machine that we create to do that. So if we want to run this, jump into the right folder, and we're going to run Terraform plan. And we can see that it's going to, looks like I didn't clean up previously. So let me just quickly destroy that. Cool. So if we run our Terraform plan, we can see that it's going to add one new resource. That resource is going to be, we scroll up, our virtual machine, and it's going to specify all of the properties that we gave it. And there'll be some properties that we'll know after the build's finished, like the MAC address, for example. So we can run the apply on that, and that will go and create the machine for us. And I'm going to really quickly switch over to vSphere. Let me know if you can see vCenter.
Yeah, all good.
Yep.
Excellent. So we can see our VMUG1 machine is currently being built. My lab's a little slow, so it will take a minute or two. But once that minute or two is passed, we'll see that it's on the right network, it's got the right IP address, it's got the right host name, and in the Terraform output, we'll see the hello world script that we gave it as well. So we can see it's using the credentials that we gave it in Terraform to run all of these tasks. It's going to power it on. So I am just curious, have many people here actually used Terraform in anger?
Regrettably so.
Yeah, I have.
Excellent.
Hands on up here.
I gotta admit, my current client, we're being forced as the only way that we can consume a public cloud provider through Terraform. So it's proving interesting.
Only thing I would say with that is be careful of your state files. There has been a few instances where I have genuinely taken out a production environment because the state files got, should we say, muddled between users.
Yeah.
It wasn't the best thing because it took out the firewalls. So I was like, whoops.
Yeah, definitely need a proper remote backend for collaborative use.
Yeah, I think that's the point. Loads of people use Terraform quite heavily, sort of by themselves, and it's awesome when you do that. And then when you've got when you start scaling it to several people, you need something to manage state really carefully.
Yeah,
that is for sure.
Excellent. So we can see here the machine's been built. It's got the notes that we gave it. We can give it a second. We should have an IP address pop up. It was there before. There it is, 240. So that's the one and the host name that we specified in our configuration file. So if I stop the sharing and switch back again, sorry, this is going to get very old very quickly. Cool. So you should now be able to see VS Code has created the machine. Excellent. Is that sharing okay?
Yeah, we see the VS
Yep.
Code.
Perfect. So machine created. Let's switch back to presentation. Okay, so that's just a pretty simple example using the vSphere provider. Next up, we're going to have a look at the VRA provider. So there's sort of two main things you can do with the VRA provider. You can set up all of your infrastructure. So things like creating projects, all of your cloud accounts, your blueprints, your image profiles, size profiles, network profiles, all those sort of things. The other thing you can do is you can consume your infrastructure. So you can deploy VMs based off your blueprints to your public and private clouds. You can deploy your Kubernetes clusters and namespaces. You can run your code stream, CI/CD pipelines. You can request orchestrator workflows, all of those sort of things. So two main use cases, one for your sort of VRA admins and one for your VRA users, I guess. So I'll have a quick look at the VRA provider. Let me switch back. Excellent, that should be working. So if we jump into our VRA provider, and we'll create a project. So if we look at our code, so we've just got project.tf. So again, we specify the provider we're going to use and any properties that we need. So for this, we're using a token to connect to VRA, and that is defined in our TF vars or variables file, along with a few other properties. So we need to grab just one data resource, and that's the VRA zone, and it's going to look that up based on the zone name that we specify in our variables, which is this one here. And that's just going to connect to the same vCenter environment. We then create a resource of a project, and we're going to give it the name and description, again, that we specified in the variables file. We're going to assign it to the zones so that you can straight away consume from the vSphere environment. And we're going to set some limits on, you can only deploy 5 instances, can only have 16 CPUs, 16 gig memory, and 1 terabyte of storage, for example. And we can specify who the administrators, the users, and the groups in these fields, and specify our machine naming template. So if you want all of the VMs in this project to be built with a specific name, you can specify that here. So we'll quickly run the plan on that. And it's going to add one resource. So we'll quickly apply that while I switch back to the browser. There we go. And if we jump over to VRA, have a look at our projects, we've now got our new project created. And it's assigned the 2 roles that we wanted. And we can see that we can provision to the vSphere environment with those 5 instances, 16 gig memory and 16 CPU limit, again with the terabyte of storage. And our machine naming template is specified as well. So that's nice and easy. We'll switch back to this one now. So creating the project is sort of the VRA admin's role. For the VRA user's role, the thing that they're going to want to do most often is request a deployment. So we'll just take a quick look at what that looks like. So again, they'll need to specify their token to connect to VRA, and they'll need to know the machine blueprint name that they're deploying. So in VRA, I've got a blueprint called GCP machine. It's within the management project. and we want to create a deployment called VMUG London deployment. So nice and simple. We'll quickly go through the Terraform file. So again, specify the provider and the properties. The data source that we need to grab out are the project. So we give it the name, it will find the object. Again, the blueprint that we're deploying from, we give it the name, it will find the object.
I think you might need to switch back to your.
Sorry.
Sorry.
Cheers. How's that?
Yep.
Perfect. So yeah, config, data sources, and then we're going to create a deployment. The ID of that we grab from the data source. The deployment name we've specified as a variable. The project, again, we've got the data source here. And there's a couple of inputs, for this blueprint. So we need to specify the flavor, so the size, what image we're deploying, and what tier we're deploying it to, whether it be app, web, or DB. Then at the end of that, we're going to output all of the properties. So nice and simple again, we just run the plan. We can see that it's going to add one resource and it's going to output the properties by name. So we'll just run the apply on that. And that will take a couple of minutes, but I'll switch over to VRA. And we can see here VMUG London deployment has been kicked off. And what this blueprint is it will actually create a machine within GCP for us. So it's done all the approvals because we don't have any. It's creating the network within GCP. So from here on, it's only as quick as GCP allows it to be, basically. And we create the machine. So at the end of this, you'll get your machine. You'll have the IP address, which you'll see in the output that we provided. And we can have a look in GCP as well. We can now see our machine being built. So I think what the real value, I believe in this, is that you're basically obscuring the complexity of your public cloud to your developers. So all they need to do is, whether it be through VRA UI or Terraform or whatever, to deploy a machine, they only need to know a handful of values. So what OS, what size, and what tier, for example. It could be what region, it could be whatever properties you want to give your developers. And then in the background, VRA does all the mapping for you. So it will decide, okay, does this machine live in vSphere? Does it live in GCP? What tags do I mandatory need to apply to the machine? All of those sort of things that usually get missed. You're just automating those steps for your users. So we can see that machine is created. Go back to our deployment, it's finished. So I'll switch back to code.
Just out of interest, Gary, do you get the share desktop option now?
Oh, let me give that a go. No.
Okay,
Sorry.
all right, fine.
It might not take effect to the next meeting, Simon.
Yeah, okay, no worries.
Yep, so because we specified an output, we can see what it's actually created, and we can see what networking details it's given it, all of the sizing. There's the IP address that it's grabbed from our pool. And yeah, that's created our machine for us. So let's flick back to PowerPoint.
Presumably that deployment we've done there is fairly transparent between, I don't know, GCP, AWS, and Azure.
100%.
Yeah,
Yeah,
again.
I've just used GCP just because that's what I'm using in
Yeah.
current project. But yeah, exactly the same for AWS, Azure, even vSphere. But yeah, so let me switch. We'll do one more thing quickly. Actually, let's go this one. Excellent. Are you able to see PowerPoint?
Yeah.
Excellent. So that's all well and good. We can consume VRA through the UI, we can consume it through the API, and we can now consume it through Terraform code. But there's another functionality on top of that, which VRA has added, which is about adding your existing Terraform code. So you might have Terraform code that creates an F5 load balancer along with ServiceNow integration or your Datadog integration or all of those providers that Terraform supports, but VRA doesn't. So in VRA, we can actually provide those configurations for users to consume. So if we have a look at my this diagram here, thieved from VMware. So basically in our blueprint designer now, there's a new option for Terraform configurations, and we can point the blueprint to a Git repository with those configurations, and we can present them in the catalog to be consumed as they would anything else. So one of the big sort of pain points of VRA is that it doesn't support a lot of things. For example, F5 load balancers or monitoring tools like Datadog or any of those things. Whereas with this is you can provide the capability through VRA, but in the background, it's actually running Terraform code to provision those resources. So the benefit of that is one of the big pain points we mentioned earlier was shared state. So VRA becomes the shared state provider. And you on that state file, you can run day 2 actions, you can import workloads, all those sort of things. And as I mentioned, those Terraform templates will now be available within the Service Broker template or ServiceNow if you use that integration. So like we sort of said, all the benefits of shared state, the benefits of VRA, so we can actually enforce provisioning policies, so we can set lease times, approval checks, costs, version checks, all of those things that VRA does really well that maybe Terraform doesn't. So we can sort of get the best of both products, I guess is the way of looking at it. And of course, from your user's point of view, if they're already using the self-service catalog, well, Terraform resources just become another consumable item, basically. And of course, we can do hybrid blueprints. So you could specify, say that there's a new cloud provider and VMware hasn't added support for it yet. We could specify that in the template as this ABC Terraform, for example. But then we want to also hook it up to our existing Puppet integration, which VRA does have. So we can put them both on the same blueprint. And of course, we can run extensibility on those things as well. So our ABX actions and our VRO workflows as well, which I think where's sort of the main value of VRA is around the extensibility options. So what does that look like if we stop and switch back to code? Excellent. Over here, so in our request anything deployment, let's have a look. So we've got our main file, which again just specifies that this time we're going to be using the Google provider. So we're not using VRA at all. We're going straight to Google to get this information. We're going to provide it some credentials. So if you've ever used GCP, you know that service accounts output a JSON file, and that's fine there. I won't open that up, but it's got the credentials in it, and the project that we're going to specify, that we're going to link it to. So we'll have a look at our file. So this one's going to be a bit more complex. So we're going to create a pool of VMs, an auto-scaling pool of VMs with a firewall and a public IP address. And we're going to create a web page that's serviced from those VMs. So for that, we need a couple of different resources. We need a public IP address. We need to create a firewall that allows internet access over TCP to the port that we're specifying, which we've got specified as port 80. Then we're going to create a forwarding rule. So we're going to forward everything to our compute pool that's coming in from the IP address. We're going to create that target pool, and we're going to create a health check that checks sort of those values for how frequently it needs to check, and it's going to check that our port 80 is up. Then we create our instance group manager, which has our target pool specified, and we create our autoscaler that specifies I'm going to need a minimum of 2 replicas, a maximum of 8, and a cooldown period of 60, so that we're not going to spin up a heap of machines up and down all the time. And we're going to do that when the CPU utilization of a machine gets to 50%, then we're going to increase or decrease the number of VMs as required. The VMs that we're going to deploy are F1 micro machines based on Ubuntu 18. We're going to run that in our home lab network with that subnet. And we're going to create the website, which is basically just a basic HTML file being run on a HTTP server on the VM. So we can switch to that folder. Run our plan. All looks good. 8 resources to add. Run our apply. And that's going to go off and create the machines for us. So that's how your developers would probably do it today. And they would need to have a credentials file and do all of that to talk to Google directly. Whereas an easier way would be to provide this information within VRA. So if we flick over to VRA, we can create a new Terraform blueprint, and we're going to call it GCP MUG. Cool. So what we can do here is we can actually specify that we specify the Git repo that exact. Did I switch the screen? Yeah, sorry. There we go. So basically we go new Terraform template, and we're going to call this a MUG. Specify our Git repo, specify the commit and the directory. And what this will do is grab our Terraform code in that Git directory. We can specify what version of Terraform we want to run, and it can find, okay, we're using the Google provider. We're going to deploy it to this environment, and we can create that. And we can see one resource here. And just like everything else, we can present it to our users and they can consume that. I won't go through all that because it does all take quite a bit of time. But if we switch back to code, we can see our 8 resources were created. Just go through those. So the address, the firewall, the instance templates, the health check, forwarding rules, all of that's been created, and it's outputted our public IP address. It won't be instantly available, but if we give that a minute or two, or 5, our web server will be available on that public IP address. And that will probably take a few minutes. So I'll just flick through the rest of the slides. So if you are interested in any of this, I've got a blog with all of the steps. The Visualize Automation Cloud site has some good information too. Terraform can be downloaded from here, and the VRA provider actually gives you a good list of examples with the link there if you're interested. Well, that's pretty much it. The creation does take a couple of minutes, so we can awkwardly wait for that, or if there's any question, oh, there we go. Perfect, good timing. So that's our public IP address fronted the 2 or 3 machines. There we go, base instance. It's actually built 5 machines. Yeah, so there we go. Any questions?
Nice demos, Gary. Are you using this in your current projects? Is it something that you're using in anger, or?
Yeah. Basically, it's a GCP project or VRA and GCP project, and the only way to consume GCP is via Terraform code. So it's been a very quick get up to speed on it.
What, you didn't feel like writing dynamic types and custom resources to consume cloud native services?
Yeah. It's been good fun.
Yeah. And is that using the service, the Terraform provider service within VRA?
At the moment, no, because we can do everything using native VRA. So we're not using the VRA service provider yet, but there is a use case that we've talked about that might go down that path.
Yeah. It's a good demo. I like it.
Cheers.
Yeah, always good to see demos. And I did verify that it is actually a real demo because I can get to your IP address. So obviously it wasn't.
Yeah, cool.
Should we test his auto scaling if everyone hits it and we refresh multiple times?
You mean should we test his credit card limit?
Oh, I'm gonna regret that.
No, that was really good, Gary. So thanks for that.
Awesome.
It's cool. So I mean, what other stuff have people done with Terraform? I don't get to do much more than drive PowerPoint these days, it seems. But I have done a bit of experimentation with Terraform on Azure. Right? I mean, I think it's been a fairly steep learning curve to get going, but it does, does seem quite powerful.
Yeah, I think the entry level to it is actually not too hard. There's a lot of examples out there. It's when you start creating things sort of dynamically and looping through variables and you start building different layers of complexity on it, you can get to some really, really complex solutions with the Terraform providers, which, I mean, I was looking before. So previously, Terraform was one of my responsibilities within the team that I'm in, and it's not now, so I don't do so much of it anymore. But we were looking at building our field demo environments, so we rebuild every night. We were looking at rebuilding them in VR, so using the VRA provider, to rebuild whole VRA demo environments each night, which at the moment we run Python scripts through pipelines, which can and does fail on a semi-regular basis. Whereas the Terraform provider, like once you've got it sorted, it's very unlikely to fail. It's pretty robust.
I'm going to put a terrible plug in there, but I'm getting back into Terraform again. And I've kind of taken a bit of inspiration from kind of the days of Autolab and the VTardist, as Simon will probably remember very well. And, taking things like from Alan Renouf and kind of William Lamb stuff. So essentially what I'm trying to do with that bit there is I'm trying to get more used to the whole kind of, even that blog there that you're reading, if you click on the link, is built from a pipeline. And the aim of what I'm going to try and do with this project is, if you have a vSphere environment setup or a very basic, cloud setup, is you'll be able to build a lab with hopefully a few variables set in a file and away it goes. Or that's where I'm trying to aim to it. So, I think many of us are fed up of rebuilding our home lab when a new version comes out, be it Windows or whatever. You've got to dump the ISOs in a place, it builds everything with Packer and then calls Terraform and starts building that all the way up to the Active Directory domain as well. It's just, remote provisioners can sometimes not work the way you want with Terraform.
That thing about Autolab, Sam, you did an excellent blog on doing it in Ravello, which I managed to also spin one up, but unfortunately got taken over by Oracle, so that sort of dead-ended.
Well, that's again, there's a bit of inspiration for this really as well, is that eventually I want it to be kind of somewhat platform agnostic, so you can just set a variable in the file and go, well, do you want to build it in, you've got a vSphere environment, build it there. Do you have a GCP environment, build it there? Do you have a AWS environment or Azure? And that's how I'm going to slowly build this project up, is you say that my domain is called blah, this is my IP address range, and then you basically say go, and then it will go make sure that it's got the files it needs, like the ISOs or what AMIs you want to use, and it will just kind of do it all. It's just going to take me a little bit of time to do it, unless anyone wants to give me a help with it. I
always think with those things, the iterations are what take the time. I mean, I remember when I did all the stuff in PowerShell, right? By the time, it wasn't running on the most powerful hardware to start with, but by the time you start to get it to deploy everything to run through the configurations, because a lot of the stuff has to be done sequentially, right? You've got to have DNS before you can have this, before you can have that. And it invariably fails at like 99%. You know why it failed, so you fix it, but it then takes 2 hours to go back to the beginning of the run again, which is a little bit frustrating. Which is why I think those things do take time, but they're really cool when they work.
That's why the code in there is not moved for about a week, because it's just not quite played the way I want it to. But it's going to get there. It's just interesting way of doing it. I've tested it again. The driver is it Windows 2022 is so say out or whatever they're going to call it, and I thought, well, the lab needs rebuilding, and I can't be bothered to build a domain. I can't be bothered to do this. Why can't I automate it?
Or dare say you've run out of a license for vCenter.
Well, there could be options like that. Accidentally, you're running out of licenses. Oh, well, just blow it away and you can build it again. And as you said, within 2 hours, I can have everything back up and running. And it's useful for me sometimes to test iterations. So if I've been tweaking something and then maybe the company I'm working for, we might release features, it's good to test it against a completely well-known vanilla environment versus one I've tinkered with.
If you don't mind me asking, Gareth, are you doing that as a public GitHub repo?
Yeah, there's a GitHub repo there. So
nice.
And that's why I was looking at some of your stuff and how you're running scripts to how I'm doing them.
Yeah.
So I'm personally pushing a lot of the scripts to the machine, so I know they're running on the machine and there's no firewalls or anything in the way. And it's just different ways of doing things. And that's why, if anyone wants to help, I'm all ears, because I think it's one of those community projects, a bit like Williams Lamb scripts and whatnot. I want it to be there to help everyone. And even people just starting with Terraform or Packer, they've got something they can grab and it will do the most basic jobs and kind of start working.
Yeah, it's nice
Yeah.
to have a framework you can tweak.
Yeah, well, that's the biggest thing, is trying to make it as a framework, and that's what's taking a lot of the scripting in there and trying to get it to pull in variables. And the eventual aim is to then have an XML file that is probably going to use PowerShell as a wrapper that will then go off and, you know, basically pull in that file and go, okay, I'm going to build Gary's lab today, or I'm going to build, you know, Joe's lab or whatever. It will then go off and do it. It sounds like the biggest problem is putting in so much sense checking. Like even something simple as I've had to write code within Terraform to go wait for a service to poll before it continues. Otherwise, as Simon invariably says, it fails at like 98% and you have to start all over again. So it's adding bits in there saying, okay, I've even made I actually wrote the script for you might see Michael Cade's Veeam project that he did. And that was one part of enhancing it. It was waiting for a service to become available before it would continue the build, so it could be fully automated. It's just all those little bits that just take time.
Yeah. Do you come across? I mean, one of the, I guess when I look at doing this elsewhere on some of the things I've been working on, I always think it's better to work with, or at least in my experience, the kind of native constructs that you get out of, particularly all the hyperscalers, right? You know, AWS, GCP, so they give you a really good abstraction on top of everything they run underneath. So to me, sometimes Terraform is obviously an abstraction that sits in front of that. It gives you a really good bit of portability, but I guess the trade-off sometimes is that, presumably if AWS release a new feature, you're presumably then dependent on some kind of provider in Terraform to be written for that. I mean, what's people's experience of the kind of how long that takes to get some of those providers, or even how easy it is to do it yourself?
I've seen it in reverse. Oh, sorry, Sam. I've seen stuff happen in Terraform before the Amazon API a few times.
Yeah. Well, I was going to say, for Google specifically, they've got a commitment that any GA feature will be supported in Terraform at release date.
Yeah. You'll find it the other way around. You know, when we were doing, what's the stupid other file services on AWS, we found it was available in Terraform before it was in their own API. And CloudFormation, it was stupid.
Yeah, and so you can automate the build as well. So I know with the VRA SDK, which is what the Terraform provider is built on, we take the Swagger from the latest release. So we take the API Swagger file definition and we use that to build the VRA Go module, the SDK Go module, which then trickles down to the Terraform provider. So you can if you've got a well-defined Swagger, and I'm not saying that our Swaggers are that well-defined, but if you have got a well-defined Swagger, you can actually automate the build of your Terraform provider almost completely. So I think you'll see that, like as a module gets more and more more consumed, more people are using it, they're relying on it, then the build process starts to get automated and it catches up very quickly to services. But having tried to write Terraform module myself, there are smarter people than me doing it by a long way.
Cool. I think there were some links that you had maybe in your deck, Gary. I mean, is that something you can maybe paste in the chat so people can do some?
Yeah, of course.
For some further reading. I think those would be. I mean, I'd certainly personally be quite interested to go and have a look at some of that.
Yeah, I'm already looking at your stuff, Gary, and going, well, I might even add some of this stuff to the stuff that I'm doing, just to enhance it even more.
As I say, we didn't even touch Packer today, but at least in my lab, I've got sort of all the flavors of Windows, Linux, just auto patching, creating a template every month, as a few others in the community have.
So I guess just as a bit of a tangent, because I've not really played with Packer. I mean, how does that work? Does Packer provide you presumably do some kind of inline streaming of patches into those images, into the WIM images?
So you can basically just build it off a known source. So for Windows, for example, I've got the ISO on one of my vSphere data stores, build the image, and then it runs, there's like a Windows Update provisioner. So you can specify I want to run all patches that match this query. So not a preview patch, for example. And it will, as part of the packer, just patch it completely up to date, turn it into a template, and then bring it back so that you can consume it.
Okay, so the output's a templated VM.
Yeah. And I used to use this a lot for, gosh, it can sound old school, but keeping consistency across things like remote desktop images. So within reason, I would use an ISO on my vSphere. I'd use a certain version of AMI on Amazon, and then same on Azure. But at least then I knew those were built to a very specific set of criteria and had the consistent app across them all. So if a user hit it, the only difference would be what platform it's running on, with a slight variance in the underlying ISO potentially. Otherwise, it should be consistent across clouds. Well, that was the goal.
Yeah, that's one of the nice things about Packer is you can specify multiple targets as well. So you can build the same image to all 5 different vCenters or vCenter and AWS and GCP. You can do it all over the place and basically spray your build wherever you need it. And the idea is that obviously you're going to get the same image at the end of it. I think you can also do it based off of an existing template as well. So you can actually deploy and update a template using Packer, as far as I know. So like if you want to just streamline your patches into the existing image, then you can do that. But typically, if you've got a Packer template that's already building your template up to the point where you've where it's good enough to be your template, then it doesn't take much to just rebuild it from scratch with Packer.
How do you get the? So I mean, if I think about the way it's been a long time since I've had to do this, right? But you would get a vanilla OS image. I would usually run the offline WSUS utility that would then basically you select which patches you want, and it would squirt them and patch that machine up, and then shut it down and convert it to template. But I mean, how do you get Packer to inject those patches in? Do you have to run it interactively inside that machine, or does it need some kind of agent?
I don't know how the other guys are doing it, but I just use the auto attend XML and just put it in there.
Okay, so you kick it off. Fine. Okay. Yeah. Gotcha.
Yeah, you can do it like that. You can also run scripts like post deploy and at different stages. There are actually quite a few modules. The Windows Update modules, I think Gary mentioned he uses that, which obviously allows you to run Windows updates against it and install the packages you select or everything. It's quite useful. I use it in our labs to provide the various different flavors of because we have 5 or 6 vCenters in our field demo labs. Each vCenter needs to have the same image flavors around, and so we use that to build and spray that. And also one of the things that we're doing now is through pipeline automation, we're actually building the image, adding it to VRA, and then deploying that image and then running salt stack config against it to get a security checkbox that it's not got any of the vulnerabilities and not got any services running that shouldn't be and all that sort of stuff. So it's taking that whole like DevSecOps config kind of idea and saying we're actually going to automate a security scan before it then gets released as a template. So you can make it really complicated if you like.
Ooh. Very good. Got any other questions for Gary before we do the closing? No, if not, okay. Thanks, Gary. I thought that was really cool.
Awesome. Thanks, guys.
So let's see if I can. We'll do this bit quickly. So Mr. Bagley is going to join us about 1:15 to test. Actually, we're going to test his presentation capabilities with Zoom, but it seems I think the problem's actually on our Zoom settings. Right. So hopefully you can see the slide that you're not supposed to see. So you know where you are. So these are obviously our next event really that we definitely committed to, and we've definitely got a will run date for, is the National VMUG, which will be on November the 25th, hopefully at the Space Centre. So I would keep an eye on vmug.com. If you're already a member, you'll get some emails a bit closer to the date with some of the details as they start to firm up. I suspect we will be running kind of a hybrid event, so we are obviously going to do that in person, but we will probably at least provide the recordings that we usually provide, but maybe we'll try and see what we can do in a slightly more interactive manner. For London, so we haven't yet obviously planned out our 2022 dates, so we will be doing that as soon as things start to open up and the people are back at Tech UK, and we can look at how many creators there are in their schedule. I would suspect we may be a little bit challenged for some of the dates. We may not be able to run on the Thursdays that we usually run on, as I suspect they're going to have a kind of backlog of events that will be rescheduled into 2022. So again, keep an eye out for that. But all things being well, 2022 London should be back to normal, whatever normal is. As ever, email, website, and Twitter hashtags are always ones that we keep an eye on. So we have recorded what we've got here today. Gareth's going to do the brilliant job he does every time of chopping the video up and getting it up onto YouTube. So the YouTube channel the link's a bit further down, but you can just Google LonVMUG YouTube and it'll get you there. I think we talked about that. That's the bottom is the link for what we're doing for the link for our YouTube channel is at the bottom here. So fingers crossed we will be doing live in-person 3D stereo Mario Nation people. So we didn't get very many people tweet exactly what it was they were hoarding, so I took an executive decision, and we are going to award our prize to Michael, who I don't think is on at the moment, so I'll get in touch with him and we'll send him some lovely VMUG prizes. Again, honestly, you've seen some brilliant sessions here today, and those did come from the earlier call for papers submissions that we had, so they do turn into real things. And we're really interested to see some kind of interesting content, particularly, personally speaking, particularly where we're doing those kind of pipeline things, any kind of automated configuration of stuff, they make for actually really good VMUG sessions and demos. I don't underestimate anybody on this call how much effort it is to put those together, putting those demos together, and without fail, they fail just before you go on stage and have to present them. So it's difficult. It can be quite stressful to put together, but you can get a lot out of it, and certainly the people here would be interested to see what you've got to talk about. So with that, we're pretty much to the close. So this is our last London event. So do keep an eye out for the national one. We're a little bit down on numbers today because of holidays and various other things. I've already seen there are quite a few people watching on YouTube, and certainly when we put the recordings up, they get really good traction there. So Gary, we'll drop you some of the links as well. So once the videos are up, if you want to maybe link to them on your blog, so if someone wanted to come and catch up on that session, they can do that directly. So with that, it's 4 o'clock. I make it beer o'clock. So I shall finish the terrible slide that I put together for this. So there you go.
So I should know this. That call for papers, is that the same for MusicCon?
Yeah, so, to be honest, there are really two, right? There's the one that we always run, and VMUG themselves do have a call for papers as well. So we'll end up with a hybrid of the two. So we're going as wide as possible.
Should do. They're really good today, though. Thank you.
Yeah. So thanks everybody for joining.
Yeah.
Oh, nice.
Feel free to hang around. I'll be here for at least the next. I'll be around for at least the next hour before I've got to go and deal with scouts and whatever else it is I've got to do today.
Indeed. Have we got to? Did you say Joe's going to join?
Yeah, so Joe's going to join about 15:15, and we're going to do some testing. I suspect it may not work, but we'll see if it looks like it's a per meeting setting. But I think we've got to the bottom of it, hopefully.
Okay. Good, before they all get paranoid about the fact, but it has only been with VMware.
Yeah, that was what was confusing me, because we tried this before. everybody else could share desktop, but the VMware speakers, which is quite. I don't know.
Yeah, I think it's across the two. I think there's two types of organization settings. I think something's come from the VMUG side, because I'm sure that setting wasn't on in the past. I wonder if they've kind of done a spray and pray to try and help certain VMUGs out.
Yeah, or maybe it was a Zoom. Yeah, or
Zoom
even
might have brought in. I can't remember seeing that there last time we were in there.
Yeah, because I remember we specifically